Hopefully everybody had a good Friday off. I know there was some confusion. I just wanted to cover this real quick. I know there's some confusion about the class schedule from quite a number of people. So I think we need to do better on our end about communicating with clarity exactly what the class schedule is. So every week, class is scheduled for Monday through Thursday. I'm converting because I'm in Mountain Time, so we always put everything in Pacific Time. So Monday through Thursday, 6 p.m. to 8 p.m. Pacific, and Saturday, 11 a.m. to 1 p.m. Pacific. So you'll have to convert for your time zone as is appropriate, but that's the course schedule. So we don't schedule class on Friday. And if any of those scheduled days fall on a holiday, then we'll give you as much notice as we can, and we'll probably take the day off, and we'll recuperate the lost day on the other end by just adding a day to the end of the course schedule. So this round happened to start on the 6th rather than the 5th because the 5th was 4th of July observed work holiday. So yeah, that's the general schedule, just so that's clear. And yeah, again, I don't want to put anybody on the spot. If you like weren't clear on that, like, no worries. I think we might need to change some copy around how we're communicating that. Somebody brought to our attention like where that's stated is a little more open to interpretation than we intended. So no worries. All right. So I want to go over that overview again. This is something that a concept that I want to visit and revisit, obviously. So let's kind of turn this into a breakout. I know I went over this just a couple times, but I'll leave it to you. Go ahead and put it in Slack. Your best recollection of the basic topics for the overview. You don't have to go in depth into each topic and build them out, but just what are those 4 basic topics that I talk about for the overview. And I'll just put a minute or so on the clock here and give you all a minute to put that in Slack. Well, I'll do another minute. I see a few answers. And if you don't remember all of them, just give your best approximation. The purpose of this is not for me to like judge who is getting this right or wrong, but to allow you the opportunity to engage in thinking through this rather than me just saying it, because I'm about to say it. Okay, cool. We'll wrap that up there. Thank you for doing that. I know maybe it's a little bit of a stretch, but some of you got it for sure. Okay, so let's look at this overview. Now, to be clear, this is something kind of from my own brain. This is the way that I look at this. You could one could probably think of an alternate sort of path, or may include other things that I don't include in here. So this is I'll frame this as my opinion because it is. But the purpose of this overview, what I'm calling an overview, is to give you a complete picture of a programming language. And I use this as a schema essentially when I go learn other languages. Some languages I, by necessity, have to add other things, or I'm more or less concerned with certain aspects of this. But this is the baseline structure that I proceed from. So, I will also mention that it's not, what I'm showing here is not a comprehensive view of every feature or concept in a programming language or in Python. It's just what I think of as the foundation. Like, if I know these things, I can learn everything else that I want to learn in that language, more or less fluidly, because I have that foundation that everything else is built off of, right? So data types. So these are the types of data that you have access to. Abstraction. Abstractions. So abstractions allow us to, they make coding easier. They don't actually allow us to accomplish anything that we couldn't accomplish without them. It would just be difficult. So they are there for our convenience, for the convenience of human beings, not necessarily the machine. The machine doesn't care if we abstract something away. In fact, in general, I mean, that's why we call it an abstraction. The machine prefers unabstracted things, in that it of course, it doesn't have preference, right? I'm anthropomorphizing the computer, but if it did, you could say it prefers it. But abstraction means basically, something that is abstracted away from its more raw form in a way that is easier for us to deal with. Often that means that it's a little harder, or the machine has to do a little more work in order to unabstract that, to get it into a form that it can understand it. Now, the computer happens to be good at those kinds of operations, so it's not that bad. So that's abstractions. That's the role of abstractions. Basically make our lives easier. Control flow. Control flow is what's going to allow us to write code dynamically. And this is the topic that we're going to be covering today. Probably all of today is going to be about control flow. I want to make the whole day about control flow if possible. So, or at least, the primary material for today will be control flow. And then iteration, which is something that we'll be talking about soon. So iteration is just, or you could call this repetition. Repetition, iteration, whatever you want. So there are a number of specific strategies and tools that have maybe different implementation details and different kind of inner workings. There's a number of ways that we can repeat processes, but at the end of the day, iteration just means we're repeating something some number of times. If I have some operation, like if I print some operation, if I have this operation that I want to perform multiple times in my code, I might not know if I need to perform it 3 times or like dozens of times or whatever at the time that I'm writing the code, but it might be easy to determine or determinable how many times this operation needs to run when the code is running, after the code has started running. So I can do, I'll just give you an example, for loop. You've seen me write one of these before. We don't have to dive too deep into this, but I just want to give you an example of iteration. So I'll write a for loop here. I'll just say for I in range 20. And essentially this 20 here is gonna tell this code to run 20 times, right? That way I don't have to write this line 20 times. I can just write it once and it'll run 20 times. And you can see, cool. Obviously it gets a little more nuanced than that, but that's the general idea. Okay. So let's take another cut deeper into these. So just kind of talked about iteration, repeat operations. I think that's not how you spell that, but I'm not going to worry about it. Data types we've covered are, actually I'll leave this to you. Let's make this, let's open source this or crowdsource this. What are the data types that we've covered? I'll put a minute on the clock. Go ahead and put it in Slack. Okay, we got some answers in here. Yeah. Cool, so we've got int and float. I'll do these in one line because these are our numbers. These are just what we think of as regular numbers, more or less. In Python, we do make a distinction between integers and floats, but you know, to us, this is just what we would think of as regular numbers. Just to be extra clear about this, integers and floats can both be positive or negative or 0. Integers are whole number values only. Floats can express a number with a fractional or quote unquote decimal component. They are expressed as a decimal point style number. Both of these operate in decimal or at base 10, right? So we don't have to worry about like writing these in other bases. Just deal with them as numbers in the way that you normally would. So floats can express whole number values or numbers with a fractional component to them. If they express a whole number value, they will have like a 0.0 at the end, which will be equivalent in value to an integer value, to the same integer value, but obviously it's expressed as a float. So floats give us a little bit more precision, a little bit more flexibility, but the compromise is that they are a little bit heavier of a load on the machine to store and to process. They are encoded differently in memory than integers, and they're a little bit more complicated. And there are certain places, you'll find this out later, but there are certain places where we need sort of the clear limitations of an integer, where a float won't do. So they definitely both have their own place. Okay, cool. Boolean, we've also covered Boolean. Now Boolean is technically a numeric type. If I was being technically correct, I'd include it up here with the numeric types, but you know, its values are true and false, and that's not really the same as the numbers that we know. So Booleans just have true and false values. We're going to be talking a lot about these today because Booleans relate heavily to control flow. So this particular point relates back to this particular bit. We've also talked about none, which is a unary value, meaning it only has one value. And the value is none, right? Somebody brought up, is this the same as null? There's a small conversation about if it's the same as null or undefined or nil. Other languages, every language that I've learned and worked in has an analogous type. Python is the only one that calls it none. Usually the analogous type is called null or nil, or JavaScript has null and it has undefined, which is essentially the same thing. There's just differences in where and why you'll see that, but it functions exactly the same way. So if you're familiar with another language that has null or undefined or nil, that's the same idea with none. Void, that's another one. How can I forget void? I love C. Cool. Let's do, the other one is string. So we've covered int, float, bool, none, and string. So strings, we denote that something is a string by putting quotes around it. I like to use double tick quotes. You can also use single tick quotes. If you use single tick quotes, you can't use an apostrophe because it's the same character. So there's a way around that, and we'll kind of cover that later. But so strings are our data type for storing information and dealing with information in its textual form. So it's a way of dealing with text. So if I wanted to, analyze a book or, some corpus of research or literature or whatever, that information would probably start off as a string, and I would start parsing that string and pulling out words and features that were important to me, and I would have to figure out how I would determine what's important. And the whole wide world of string processing is complicated and interesting and important. Okay, cool. So those are our data types that we've covered so far. So quick note on data types. As you're learning, this is what, I mentioned this before, this is what I think of as analogous to, I would say there's vocabulary building to happen in all of this, but most of the vocab building stuff is going to happen in data types. The bulk of the work is going to come in understanding how and when to use data types, different data types for different things, and this is not every data type that's in Python. There's a few more that we haven't covered yet that are a little more complicated. Nothing too outlandish though, so no reason to get scared. So this is where most of the bulk of the work is going to be, in just learning different features and ins and outs of how to use the type, each type. Yeah. Okay. Abstractions, variables, functions. Variables are pretty simple. we've covered those. I wrote a function, I think the other day. You've probably seen a few functions at this point, but we haven't started covering those in class yet. Some of you are probably working ahead in the Learn material and you're familiar with functions. So functions are a bit more complicated, but they are still an abstraction like variables. Both of these are abstractions because they sort of hide something complicated under something simple. It's a very kind of loosey-goosey way of putting that, but in a nutshell, that's the idea. Okay, control flow. I'm just going to say dynamic code. Dynamic code, it's going to allow us to write code that will only execute under specific conditions. And since we're going to dive into that today, I'll just leave that there. Cool. We don't need to recap those. I want to open the floor up. If anybody has any questions in general, feel free to put those in regarding the material. Specifically around variables. I want to make sure everybody is solid here. If not, no worries. You know, feel free to ask for clarification if you need it. Okay. So I'm going to cover some material. I'm going to recover some of the material that we covered last time to do with Boolean operations, because it's going to bear heavily on today's main topic, which is control flow. So before we get into this, let me give this some context, and you'll see why I really want to emphasize it. Let's say I have two variables. A is 7 and B is 5. And let's say I want to print B is greater than A. Now I know this is you might think I'm having a typo here, which is fair. I have those, but I intended to write this. I know that B is not greater than A. It's less than A, right? Maybe I want to have something that says A is greater than B, and I'm hoping to give this example of, like, let's say I have some special code that needs to execute only when some condition is true. In other words, you know, if it's true that A is greater than B, if that statement is true, then I want to run this code. And if it's true that B is greater than A, I want to run that code. Of course, they could be equal. I could say A and B are equal. Why do I have all these spaces here? I'm going to do this here. Okay. So I only want to run this when A is greater than B, which right now it is. And we can kind of pretend, you know, this might seem a little silly because it's like, well, you know, I just wrote in those values. Like, having written in those values, I don't need some process to determine which of these is true. I can just run the appropriate one, right? But, you know, pretend that this is a more complicated program and the values of A and B perhaps aren't obvious or they're being determined from some outside input, right? Say like say I'm processing some data, and I'm parsing through that data, and I search through and I find values that I can plug in for different variables, and so I don't know what that data is at the time I'm writing the code. I write the code, and then the code processes the data. That information is determined at runtime, not at write time. So we'll just pretend that that's what's happening with A and B. Oops. And we'll go from there. So right now, of course, if I run this code, all three of these are going to print. It's not very useful. So I have to make this dynamic. In order for this code to make any kind of sense at all and to be any kind of valid, it has to be dynamic. It has to respond to situations here. So back to Boolean operations. That's where this comes in. If you look at a statement like this, A is greater than B, right? This statement can either be true or false. It's one way to look at it. So what I can do, I'll just do this with one, is I can say, I can use one of these comparisons, specifically greater than. I can say if A is greater than B, I'll put a colon, and then I'll indent the code that I want to run underneath this if. So I use this keyword if, and what if does is, here I'll kind of sketch this out. We have if condition and then colon consequent. If condition consequent, and the consequent is the consequence, the code that is executed, and there can be as many lines of code in here as I need. This is the code that's executed when the condition is true, only if the condition is true. If the condition is false, then it doesn't execute it. Okay, so actually I should, why don't I leave that up here? Okay, so if, and then some condition. So I'm using this term condition. I mean something pretty specific by condition. What I mean when I say condition is some expression. An expression is a part of the code that gives back a value. So some part of the code that gives me back a value that can be interpreted as true or false, right? Now, basically everything in Python can be truthy or falsy. I kind of try to avoid leaning on or relying on truthiness or falsiness. I try to turn things into Booleans directly. That's what I like to do. I don't know, other people like to do other things. You can do what you like. But so what I'm going to say here as a way of sort of simplifying and clarifying this is a condition is an expression that expresses a Boolean value, expresses a value of true or false. So it's a part of your code that evaluates to a true or false value. So anytime I see something, Boolean operation, anytime I see any of these, I know that this is going to give me back a true or false value, right? So the most common place to use these is in the condition portion of an if. Cool. So from here, these are the comparisons that we can use. And we can sort of modify those with not, and or with the logical operators. So between these Boolean operators and these logical operators, we actually have, it might not look like a lot, but we actually have a lot of options. There are even other things that we can do that will give us back true or false values. We'll get into this fairly soon in maybe the next couple of classes. Excuse me. We'll get into this fairly soon where we start writing functions. And a function, when we define a function, we define the process, and then we invoke that process later to give us, usually to give us back a value. That giving back of a value means that that function is an expression. And if we write a function to give us back Boolean values, true in some situations and false in other situations, if we write a function to do that, then we can use that function as a condition. And there's times when we definitely do that as well. So there are other things. This is not the only system for building out conditions, this and this, but it's feels a little reductive to say it's the primary one, but I feel like I genuinely see these used the most to build out conditions. So often when we're writing conditions, we're using one or some of these operators and one of some of these logical operators as well. So let's get a little further into this. So we can say if A is greater than B, then we'll print A is greater than B. And let's make B 50, right? And just to prove that the program is finished running, we'll be fancy about it. Okay, so if B is greater than A, then the expression A greater than B is false, right? And let's print this. If you're ever kind of confused by the condition, you're like, oh, that should be working, just copy it and print it. You can always print it out. So that's false, right? So if I go back to 7 and 5, so that's true, and then my code runs. Are there any questions about this? You feel free to put in your questions as I'm talking. I won't consider it an interruption, and it helps me know that you're engaged. No worries. I mean, if you don't have a question, then I'm just going to assume that my explanations are perfect and that everybody has full and complete comprehension of everything we're covering, which is also likely. Okay. Excuse me. Okay, cool. So I'm going to go over this. I'm going to go over this kind of anatomy of this again. We have our if keyword. This is a keyword. Notice it highlights red, kind of like these other operators and things, right? So that just means that it's kind of a built-in thing in Python. It's going to do something special. So if is a reserved keyword for doing this, right? So if checks this condition. The condition is an expression that gives us back true or false. After we're done writing the condition, this is a nice simple condition, but conditions can get much longer and more complicated than this. But after the condition is finished, we're going to put in a colon, which tells Python that the condition is finished. And now we're going to go on and write the body or the consequent of this if. Some of you are going to do this where you just write the head and then I'm calling this the head. Often the part that's indented or the consequent is called the body, some body of code. So it just seems logical to call this the head. So often you might say, oh, I've got a few conditions to write. I'll just write the heads for them and then move on and do something else and come back to that. There's a way to do that, but this isn't it. So if I try to do this, I'm going to actually get an indentation error. So this isn't, if I look at this, messed that up. So if I have that just by itself like that, that's going to give me an indentation error. And notice it says expected an indented block. If you're in Replit, your errors, by the way, might be a little different than mine. So I'm using IPython on my local machine, which I think is a different interpreter than whatever Replit uses. But yeah. So you'll get something like this. You'll get probably an indentation error. The message might be a little different, but same gist. And this is happening because when we have a line, and there's a few things like this that end in a colon like this. This colon is saying that the next line has to be indented, and it has to be some property of the head. It has to be the body to the head that was just written. So the colon is kind of like the neck, right? It says the head is finished, and now the body is gonna commence. So if you do this and you get an indentation error, look for wherever you have a colon without some indented code underneath it, and ask yourself, if perhaps you have code that you intended to execute when this was true, but you didn't execute, and go in and put a tab in front of it. Or actually it's 4 spaces, but I have my tab key set up in my editor settings to insert spaces, but Python needs to have spaces as tabs, but it's a whole other thing. So if I wanted this to be part of that, and I had this unindented or dedented back on the same level, I'm going to get this indentation error. So Python has no idea that I wanted this code to execute if this condition is true. No idea at all. Completely clueless. So in order to tell it, yeah, if this condition is true, this is the code that I want you to execute, you have to indent it. So when you've probably heard people say that Python is a white space formatted language, or white space is significant, syntactically meaningful, or syntactically significant in Python. This is what they mean. If you're coming from another language, you might be familiar with curly brackets, something like this, like JavaScript is structured something more like that. Java, C++, C++, most languages will have like curly brackets around there to say, okay, this is the head of the operation, and then the curly brackets, whatever's in the curly brackets are in the body, and then the white space is conventional but not necessary. In Python, the white space is absolutely necessary in order for the Python interpreter to have any reasonable understanding of what's going on. So you have to put that white space in there. Convention for indentation is 4 spaces. If you're on Replit, if you're using Replit, it defaults to 2 spaces. So you can change that if you go to settings. On the left-hand side in Replit, there's a column of icons, little icons. I think it's 1, 2, 3, third from the bottom. There's a little gear-shaped icon. If you click that and then go a little past halfway down, there's an option that says indent size. Change that from 2 to 4, and you'll be on a standard indent. If we end up meeting, if you and I end up meeting and working in Replit together, I'm going to have you change that setting anyways. So that's something. So this is worth noting, because let's say A is greater than B. Let's say I wanted to write something else. I can't mix and match indent sizes. I don't have to. Python will let me have an indent size that's not 4 spaces. but it has to be consistent per indented block, right? So in one indented block, which is what we have here, the indentation absolutely has to be consistent. I cannot mix and match. So I could do a two-space indent. I'll just say this is the first condition, or this is the this is the consequent of the first condition. We'll say that. So now I have multiple lines here, and I'll show you if I try to mix and match, unindent does not match. So this is another indentation level. It says unindent does not match any outer indentation level, right? So this is the outer indentation level. So it sees this indent, and then it sees an unindent, something that's indented less, right? And it doesn't match any outer, it's in between the prior indentation level, which is all the way left, and the indentation level that was standardized underneath that, which is 4 spaces. So Python's like, whoa, this is inconsistent. I have no idea what to do. It's just going to crash your program. So it needs to be consistent. And what I mean by that is it doesn't need to be close. It needs to be exact. And I see a lot of people do something like this, and they're like, oh, that's close. I know what it means. Python has no idea what you mean. So we've got 4 spaces here, we've got 3 spaces here, Python's completely confused. And this is kind of good, actually. This is actually kind of a good thing. You might think, oh, wow, it's so picky. Set up your tab key to put in 4 spaces when you hit it. Every modern text editor has that. VS Code has that. Jupyter has that. Replit has that. I mean, Atom, this has it. Any text editor will have that option somewhere. It probably will auto-detect the Python file type and automatically do that for you. But your tab key should help you standardize that out of the gate. So just make sure that indentation level is consistent and set to 4 spaces. Let's play around with this a little more. We're allowed to do, in other words, it's valid Python, we can do a 1-space indent. Please don't do this. As you can see, it's this is going to be valid code. This is going to run just fine. Python's like, oh, I know exactly what you mean. You gave me 1 space for an indent here, right? Code like this is hard to read and hard to maintain. It's not very clear that it's indented. That's a little better. Like I said, standard is 4 spaces though, so we'll just go with that. You could do more than 4 spaces. That's also going to be fine. But again, it has to be consistent. So these are both indented underneath this if, but here this is going to give us sort of the opposite error as before. So it says unexpected indent. So it sees this indentation and it's like, wait, I don't see anything that asked for an indentation. I just see something that's indented more than the line above it, but there's no reason why it is, right? So the only time to do an indent is on the line or lines after a colon. Cool. And then notice that when I do unindent something, that's your way of telling the Python interpreter that the body of this if statement is completed. You're no longer executing code in that if statement. So if I unindent something, that's like saying that's an explicit end to that consequent or the body of that code. Apologies, looks like we've got a few questions in here. So why does, somebody's asking, so why does Python use curly brackets for dictionaries? Curly brackets for dictionaries, dictionaries are a data type, not a, they're not an arbitrary block of code, right? You'll hear me talk about arbitrary code or arbitrary lines of code. What that means is just this, right? Just any arbitrary, just some random code, right? So an indented block in this case specifies some body, some algorithm to complete. In this case, I just have a couple prints, not really doing anything fancy, just a couple print lines. And in a dictionary has a very specific structure for storing data. That's what it does. So in order for Python to easily distinguish a dictionary from a list, or just determine something is a dictionary, we use curly brackets, which are these characters here, to delimit the beginning and end of a dictionary. We also use square brackets for lists. We use quotes for strings. We use parentheses for a ton of different things, among which tuples are one of them, right? So each of the built-in collection data types has a delimiter associated with it, right? So curly brackets for dictionaries, square brackets for lists, quotes, single or double for strings, and parentheses for tuples. Parentheses are overloaded in that they actually have a lot of different roles, but one of the roles is for tuples, which is a collection style data type. And we haven't gotten into the collection data types yet, but yeah, so it's just sort of a piece, like they all have a delimiter that starts and ends that. Cool, and then we've got hopefully that's helpful. Let me know if you still have questions on that or if that was helpful. The indentation, somebody's saying the indentation is more important if you are in Nano or Vim text editor. The indentation is more important if you are in Nano or Vim text editor. Are you asking if the indentation is? So, well, let me put it like this. The indentation is equally important regardless of whatever tool you're using to edit a Python document. It is important to the Python document itself. It has nothing to do with the specific tool that you use. I'm not sure if Nano or Vim try to enforce that, or perhaps they ignore it. In either case, like, you have to pay attention to it differently. I don't know. But those text editors won't make indentation any more or less. No text editor will make any indentation in Python more or less important. The importance of the indentation is a virtue of Python itself, I would say. Hopefully I'm worried perhaps I've misunderstood your question, but yeah. Somebody's asking, is indentation always 4 spaces in Python? So this is a little bit of a complicated answer. I gave a few examples of this, so you probably asked before I gave those examples. Well, I can use any indentation standard that I want. There are different, what do they call it? Style guides. It's a stylistic choice. What's important is that it's consistent, is that you do it the same every time. What's important to Python is that each block is consistent. What's important to a good style approach is that blocks are consistent with each other, right? So that if I'm if I have a project and I'm the architect of that project, and I have the agency within that project to develop and establish and canonize a style guide for that project, and people do that. People deviate from PEP 8 and they say this project, or when we write Python at this company or at this code shop or whatever, or for this specific project, we use these style rules. That's a standard, not uncommon thing to do. And some of those may deviate from PEP 8. Some of those may be highly enforced and some less enforced or whatever, but you could make a different choice other than 4 spaces. That's possible. And like I said, Replit actually defaults to 2 spaces. It irritates me that it does that though. There are certain things, and indentation is one of them, that in my opinion, I would say don't leave that up to your stylistic choice. Since it's syntactically meaningful, it can cause weird issues if you indent differently, if you try to combine code that is indented differently. So maybe there's somebody wrote some code that's indented differently than your code, and you want to integrate it in. You want to integrate maybe part of something that they're doing and copy paste it in or whatever. Let's say you have to do that 15 or 150 times. Well, if they chose a different indentation standard, you've got to go through every single line and make sure it conforms to your indentation standard now. There are linters and automated ways of doing this, and there is some error involved in those things. So the only way around it is really to just go through line by line and make sure that it conforms. So it can be, if you deviate from a 4-space indentation standard, it's technically all right. It's technically a stylistic choice, but it can cause issues down the line. So it's something that I highly recommend that you do not deviate from. It's one of those things in PEP 8 that I would say definitely do it that way. With a lot of other things, it really is up to you. Like double tick quotes, right? PEP 8 specifies single tick quotes. I like to use double tick quotes. I'm writing this code, so I get to do that. If I were working on a project that used PEP 8 as its style guide, I would have to use single tick quotes, and I would use single tick quotes. But in this case, it's what I prefer to do. So this is a way that I choose to deviate from PEP 8. It's, if you choose to deviate, just make sure you have, you can justify why you choose to deviate, and then make sure that you do it that way every time, unless there's a good and obvious reason to deviate from your standard. So anyways, I know that's a long answer, but I wanted to say it that way because I I don't want to say, yeah, do whatever you want with this and then have it cause problems for you later, So make an informed decision. It's something that you can do, but I think it's something that you shouldn't do. You should just keep a 4-space indent because that is standard. Okay. Got another question here. Oh, that's a response. Okay, cool. Let me know if those answers were helpful to your questions, or if you have follow-up questions as well. Cool. These are great, by the way. This is why I want to spend all day on control flow, so that we have plenty of time to answer these kinds of questions, and establish an understanding of indentation, because this is the first time we've looked at indentation. And it's a simple idea, but there's enough can you do it this way? Can you do it that way? What about this way and that way? What about this and that? And it's good to have time to hash those out in class. So stuff like this, I'm happy to entertain questions on, because I think it's really helpful for everybody. Okay, great. I'm not sure. I'm worried that y'all can't hear me. Can you give me a thumbs up for the people who asked those questions, or a thumbs down? Just let me know if that was helpful or not. That would be helpful for me, please. Okay, cool. Thank you. Just making sure that like y'all can hear me. Okay. Good. We'll leave that there. So just to recap, we have these lines indented. These are part of the body of this, the consequent of this if. So if this condition is true, we execute this code in the body. And then once we unindent, we're saying, okay, we're just going to go back to executing everything that's unindented. So we've ended this consequence. So sometimes people will ask me, well, what if I want to go back and execute code in there again? You know, so can I go back and indent? And will this indented line will this indented line be considered a member of the body of this if again, right? You know, and that's a fair enough question. You might think, okay, so I've got, you know, two things that I want to do only when we're in the if, and then something that I want to do no matter what, and then something that I want to do after that no matter what part. So if I try to run this though, this is just an unexpected indent. So this is not possible. This kind of logic is not possible. If I wanted this to be part of that code, I have to include it there. Just like that. Okay. Cool. So let's try adding some more conditions, right? Because we only have one condition here, so we're not really doing that much. So let's try to do a little more. So let's try to add in this print b is greater than a, right? So I could ask, you know, if a is greater than b, print b is greater than a, and you know, we could print this or not, and then if, you know, presumably if that's not the case, right, or oops, if b is greater than a, then this is going to print b is greater than a, right? But if a is greater than b, then it's going to print both. So it'd be helpful if I had another condition here. So if b is greater than a. Pretty straightforward. I got to think of a good example or how to show this. An alternative way of doing this, we have another keyword. We have two more conditional keywords, actually. We have if, and we have else and elif. And we'll kind of get into that. So when I have an if, it's saying check to see if this condition is true. If the condition is true, execute this code. If the condition's false, then don't execute the code. So if I have code that I want to execute when the condition is false, I can say else. I can say why don't I just print we'll say this. A is greater than B is false. So A is greater than B is false. So else is what's executed if the prior condition was false. One thing that I could do here, I can chain these three conditions together. And there's a conditional keyword that's sort of in between an else and an if, called an elif, right? So if asks for a condition and executes if that condition is true. If that condition is false, elif is like saying if the prior condition was false, check if this condition is true. So elif asks for a condition like this. And if that condition is true, it will execute the code in its body. And then an else, notice else takes no condition. Else specifically takes no condition. It's not like it's optional. I can't say else A equal to B. This is invalid. This is going to be invalid syntax. I can't say else equal to B like this. We're going to get a syntax error and it's going to point right there. So else is, you could think about it, if it helps, you could think about it like else is its own condition. Else is, else just says if all prior stated conditions, that's this one and this one, if all prior stated conditions were false, then execute this code. Okay, so in this case, we've got A is greater than B. I'm just gonna kind of clean this up a little bit. I'll leave that there. Let's do another section. Okay. So let's have one where I'll have 3 of these. Okay, so this is A is greater than B. This is B is greater than A. And this is A and B are equal. A and B are equal. Okay. So we've got the same thing. The only difference is just the values for A and B. So you can see we've got A is greater than B is greater than A, and A and B are equal. So in this first one, I'll say this condition is true, right? In the second one, the second condition is true. In this third one, I'm going to rephrase this a little bit. It's kind of weird to say that this else is true because it's not really, that's not really what's happening mechanically. I'll say all prior conditions were false. All prior conditions. Now, this is a little, I could be a little more precise than this. I'm going to leave it that way though. It's kind of weird, right? Because there are some conditions that come before this else that were true, right? Like this condition came before this else. This condition came before, this else, right? And both of those conditions were true. So this doesn't mean all prior conditions in the whole entire body of the code. Notice each of these systems of conditions, these are simple systems of conditions, start with an if and end with an else, right? I want to be clear that you don't always have to have an else. at the end of your conditional chains. You don't always have to have an elif. Sometimes it makes sense to just have a solo if. Sometimes it makes sense to have multiple ifs. Sometimes it makes sense to have an if followed by an else. Sometimes it makes sense to have an if followed by some elifs. Sometimes it makes sense to have an if elif else pattern, which is what we have here. So all of those patterns, sometimes there's overlap in terms of like you could do it this way or that way and it's going to work the same way either way. Sometimes there's not overlap. Sometimes one of those patterns will do and not some of the others, right? Or some of those patterns will do and not some of the others, right? So I don't want to get into what all those patterns are because that seems like kind of a lot of just arbitrary memorization. But when you're writing control flow, think about what consequence preclude the others, right? Now in this situation, it's only possible that one of these conditions is true, right? It is not, in other words, possible for A to be greater than B and equal to B. There's no scenario in which an integer can be greater than and equal to some other single integer, right? I mean, within the realms of, I don't know, Newtonian physics or something, that if that's possible, it involves some kind of math and logic that we're not covering in a beginner Python course. So these conditions preclude each other, in other words, right? It's only possible that it's either one is greater than the other's less than the one, or they're equal. But we might have logic where potentially multiple conditions could be true, right? So let's do this. Let's say n equals 75. And let's say if n is greater than 10, you might see where I'm going with this. Print n is greater than 10. So if I did an elif, n is greater than 30, print n is greater than 30, not 300. Does anybody see? I haven't talked about this too explicitly yet, chaining conditions. So when we use an elif, what we're saying is that when we use a chain, when we build a system of conditions that starts with if, which all systems of conditions must, they must start with if. Just to be clear here, I can't just jump in with an elif that's not preceded by an if, because the L part, like else what? What's it else of, right? So it has to be immediately following an if or another elif. So there has to be some start to this, right? So these are chained together. Only one of these is going to execute. There's something kind of broken about the way I have this written. I'll leave it to you to, I'm going to put 2 minutes on the clock for you to put this into words. Like, there's something kind of wrong with this. So go ahead and put it in your own words. How would you describe what's wrong with this? And I'll explain it too, but I want to give you all the opportunity to think about this. So put it in your own words and then put that in Slack. Cool. I'm skimming through some answers. Feel free to put in an answer. Please do if you are writing one. Please put in your answer. You can still work on it for a little bit while I'm going through this. And I'm just kind of skimming through. I see a lot of good points here, a lot of good kind of different ways of looking at this. So if we look at this, I see somebody said won't check second condition, and that's actually really accurate. So there is no number, again, that I'm aware of within the bounds of like normal numbers, right? There is no number that is greater than 30 that is not greater than 10. Every number that is greater than 30 is greater than 10 also, right? So if I wanted to print all consequents that are true, this is not going to work, right? This just says n is 10, and it doesn't matter how big n is. It just says n is greater than 10, which is true. It's true that n is greater than 10, but it's also true that n is greater than 30. And if the goal here is to print all consequents that are true, this is not even going to be checked. When I have a system of elifs after an if, whether I have an else or whatever, as soon as Python encounters a condition in this system that is true, it doesn't even bother checking. It doesn't even bother checking the other conditions after it until that chain of conditions is over. It doesn't even bother checking it. So as soon as this condition is true, this condition isn't even checked. So what happens is the Python interpreter sees that this condition is true, executes whatever is in here, and then it just does a really simple operation. It finds the end of whatever, elifs, and then the next line that it goes to is here. It like completely ignores all of the other conditions. Totally. Not even parsed. Other than to like validate their syntax on like a first, syntax validation pass. But other than that, it's not even looked at, not even considered. Okay. So how do we get this to run? Does anybody know how I would get this to run? My goal is to print what I really want to see on the console is what I really want to see on the console looks something like this. This is my goal. Oh, reverse the order of conditions. Somebody's saying to reverse the order. So let's do this. Let's say 30 and 10. This might have been in, response to something prior, but this is interesting, right? So n is 75. Oops. N is 75. If I reverse the order of these conditions, right, we have n is greater than 30, print n is greater than 30, n is greater than 10, n is greater than 10, right? So this will give me n is greater than 30, but I don't get n is greater than 10 now. Also, if I have a number, this changes something. So if n is 20, this first one will be false. At least sometimes under certain circumstances, one of these will run, but not, I'm never going to get all conditions that were true, right? change elif to if, make both if statements, separate two if statements. What do you mean by separate? Do you mean like just by like physically, or well, physically, I don't know, just by putting white space? I'm not sure if that's what you mean, but that won't change anything. Make elif if, yeah. Two ifs. Can you use and? That's interesting. That's a different take on that. So what I'm thinking for this, so somebody mentioned separate the two. I'm not sure. There's a few ways that I could read that. I'm not sure if this is what they meant. But this, I can have as many spaces in between here. I know white space is meaningful in Python, but in this case, it's just going to be ignored. So those new lines, extra new lines, are just the same as having it here or whatever. So I'll keep it there. The way to do this is to unbind these from each other, right? So now we have two separate ifs. So every if that is in line to be evaluated will be considered. So whether this is true or false or not doesn't influence whether or not Python will execute this line of code. So line 96 will always be evaluated, regardless of the result of line 94. So this will give me all conditions. And I kind of wanted to show this here. N is greater than 10, it's greater than 20, it's greater than 30, it's greater than 40, 50. Let's make, let's just do a few more. 60, 70, 80, 90, 100. We'll do, oops, oh, come on. 60, 70, 80, 90, 100. Okay, so n is 75. So we get up to n is greater than 70, but it stops there. And we don't get n is greater than 80, 90, or 100. So here's another trick. So let's use this system. So this will print all that are true. What if I only want to print the one, because, I can deduce that if it's greater than 70, then it's greater than all the numbers less than 70 as well. So how could I print only, how could I get this so this will only print n is greater than 70? What would I do? And I have if else at my disposal. Oh, also I forgot. Somebody suggested using an and for the prior example. I'll go revisit that. Take away the print statements. Could. I'll get a bunch of indentation errors. I forgot too. I was going to mention this. I was talking about the details. I mentioned that there is a way around this indentation error thing. If you use the word pass, you notice I'm getting these indentation errors because I commented out all the prints, right? So if I use the word pass, it'll tell Python it's basically pass is a placeholder. It's basically its use is for putting it inside of things that expect an indented block, and it's just a way of telling Python, yes, I know there's an indented, that this expects an indented block, but I don't want to do anything right now, so I'm just going to say pass. So it's valid code that does absolutely nothing, and it basically its use is to just tell the Python interpreter, hey, just ignore this. I know there's nothing in here. Don't worry about it. So pass is a way of getting around that indented block. So if I remove the print statements, that would it just wouldn't print anything. And I do want to print the one that it's higher than. Can you just iterate through the statements using a loop? Well, I could if we covered loops yet, but I can't because we haven't covered loops yet. That would be a good that would be probably the way to do this. However, we haven't talked about loops yet. It's funny. The solution to this, there's two things that changed. The solution to this actually was suggested earlier. Somebody suggested this during this one. No worries. I appreciate the suggestions. That's cool. That's fine. Reverse the order and change to LF. Cool. Nailed it. Both of the things. Got both of the things. So these need to be elifs. Okay, so elifs tell me that only one of these is going to run. But the wrong one runs, and it's going to run, like this is, in fact, the only one that's ever going to run, right? And I wanted to mention this. Notice I've created, I have all this logic down here, and there is no scenario in which this code, this part of the code that I have highlighted, will ever be executed. If a number is greater than 10, if a number is greater than 20 or 30 or 40, whatever, sure, a number could be greater than that, but it's also greater than 10. So this is going to be the one that executes. This is all what we call dead code, means it's never going to be executed. There's a number of ways to make dead code. It's something that you want to avoid, obviously, because it's dead. It means it's valid code. Python ain't going to yell at you, but it's just never going to do anything. It's just sitting there. So there's no scenario in which this code will ever be executed. So we have to reverse the order. So let's do that. Okay, let's try this again. 100. This will be 90, 80, 70, 60, 60, 50, 40, 30, 20, 10. Okay. 70. Yeah, I got n equals 70. All right, so let's try 30. So if I try 30, what's going to print out? Go ahead and put it in Slack. What's going to print out if I do 30? Dang, I always think I can sneak one past y'all. Yeah, it's going to be n greater than 20. Now I'm embarrassed that I thought I could sneak that past y'all. Y'all got it. All right, I've been foiled. Cool. So the reason, if you don't know, the reason we don't get n greater than 30 is because n is equal to 30, and we're not checking greater or equal, we're just checking greater. So the statement 30 greater than 30 is false. The statement 30 greater than 20 is true. Cool. So hopefully it's clear. I wanted to use nice and simple examples, right? Here's an example. Here's an example where we have something where only one scenario can be true. So it makes sense to use if, elif, and else, right? Now in this first example, only one of these can be true, so it's actually going to work the same if I use ifs for everything. If b equals a, this is going to work totally the same because these conditions are naturally exclusive of each other. But it's still an advantage to chain them together because as soon as I find one that's true, I don't need to bother checking the others because I know that that one is already true. I can just continue on to the next. Let's see here. So same for these other ones, right? So these are where the conditions kind of exclude each other naturally. And this is a good example of if, elif, else, right? But it also shows us that there are situations. This next example shows us that there may be situations, right? These two, where we want to do multiple things because multiple consequence or multiple conditions may be validly true at the same time, right? It's valid to say that 75 is greater than 10, and it's also valid to say that 75 is greater than 30. Obviously, this is just a iteration on that theme, right? But depending on what I'm trying to do, maybe I don't want to, maybe I don't want a lot of information that is essentially redundant. Maybe I do. I genuinely might. Maybe I just want the one that is most significant, tell me which number n is greater than, and I can infer the rest. All of these are potentially valid scenarios depending on the type of problem you're solving. So you don't have to remember these necessarily as forms, really. The thing that I want you to take away is that there are multiple patterns. Not necessarily what those patterns are, but that there are multiple patterns. It's logically different. I get a logically different result when I have a bunch of ifs together. Now, the way I think about this is each if is the beginning of its own chain. These ifs are all independent of each other. They don't, if one executes, it doesn't tell the other one, any of the other ones not to execute. They're all going to get checked. Every single one of these is going to get checked. Now, checking a condition tends not to be, at least in this scenario, in a lot of scenarios, tends not to be that heavy of an operation. If you want to get really deep into the nitty-gritty of optimization, yeah, I guess you might be doing extra work that you don't technically need to do, but does it really matter? In a lot of situations, the answer is probably no, it doesn't really matter. And then, I get a logically different result doing consecutive ifs than if I chain together ifs and elifs, right? And I maybe could even say here, I could say else n is greater than 0. Maybe if I wanted an else, right? One thing to mention about else, when I have an else, it terminates this chain of conditions. I'm talking about conditions being chained together. Hopefully that's clear why, right? Because when conditions are, when I say conditions are chained together, I mean that they're in a system where only one of those links in the chain, or only one of those blocks, is going to be executed. So chained meaning that they are sort of bound together, they relate to each other, only one will execute. That's specifically what I mean when I say they're chained together. So these are all in a chain. These are all just like independent links that aren't linked together. They're just ifs. So again, the takeaway here is not remember these specific patterns. It's there are different patterns. Just be careful, take your time, and think through each control flow pattern. Now, when I say be careful, take your time, I don't mean sit there and think about it before you write any code. It's usually, the way I think about it is like, it's usually better to think through a problem with by typing in your text editor than it is to like sit there and like look up at the sky and wax philosophically about what the problem is. There's a little bit of that, but it's fine to try multiple things. Definitely want to experiment. I mean, worst that's going to happen is you're going to get an error or your code's not going to do what you intended it to do. And if you're like, well, it's got to be one of these three things, then just try each one, see what the result is, and figure out how to test that, how to confirm that, what you want out of it, and then adjust from there. Cool. We've made it through Boolean operations. Ah, this is great. We're really digging in deep. I've always done this lecture as like a part of the variables lecture, and it's nice to have a full day to really just take our time with this. We haven't really got into logical operations, and somebody asked about this in a previous problem. I think it was this one with using and. And we can kind of talk about that. So I'll give another example of this. I know we've gone over time for what I'll usually take a break much earlier than this. I think this is a natural kind of a breaking point. Let's just reconvene at it's 39 after the hour now. Let's reconvene at 44 after the hour. We'll take a little break now. Sorry about that. Generally, I will try to keep the break in the middle of class, but. I'm gonna go refresh my water. The floor is open for questions if you want, and I'll answer questions when I get back. Okay, cool. There's 44 minutes. All right, I'm gonna give folks a second to sit down. If you can hear my voice, then we're ready to start again. Cool. So get into a little bit of the and or and whatnot. So back when we were doing this, back in the way back when we were working on this one, the goal was I had started with code that had been chained together. Just do this. We had this elif in front, and it was giving us, we had some dead code, right? In this example, we had dead code because the elif is excluded if the prior condition is true. The only scenarios where the elif's condition is true are scenarios where the prior condition is also true, so therefore it's dead code. Its condition can't be true unless some condition before it was also true, so it'll never be executed. So the goal was, how do we get this to turn in to give us this, and the solution was to give ifs. Somebody mentioned, can you use and I that wasn't the solution that I had thought of, but there's a way to do it. Let me copy this stuff, or I'll put this actually in there. So this would be an alternative, and it would behave the same as the two ifs, right? I think it's safe to say that this isn't as elegant looking, but it'll do the same thing, right? So it'll give us it'll give us, if the number is greater than 10 and 30, it'll give us both, and then, oh gosh, I don't need this. I don't need that middle condition, because that would have been dead code. Or that would have made this dead code. So if it's greater than both, we'll check the both condition first. And we could do it that way. Now, in this scenario, we could, let's see, sorry, let me just isolate these from each other. Okay. In this scenario, it's greater than both, so we could do that. We could also do that. And this will say greater than 10. We could also check if this condition is greater than 30, and if it is, we could print greater than 10 and greater than 30. Right, so I guess that somebody also suggested reversing the order, and maybe they meant also adding in this second line of code. So perhaps I didn't glean that they were implying that as well. So there's a few different ways that this could work. But this if I think is the simplest, because this is just a scenario where, to me, the way I think about this is, here's a scenario where we have multiple consequences that are individual consequence of their own conditions, but they can both be true. Since they're not exclusive, I think about that as individual ifs. That's the way I think about it. And it's just kind of simple, straightforward, consistent pattern. So. Okay. So with the logical operators, we don't need to get into these as much. The one that I probably use the most is not, and sometimes it can be really easy to check one condition, but you just want to there are certain situations where it's easy to check one thing and hard to check its opposite, or harder to check its opposite. But you want to execute the code when the easy thing to check is false. So if you want to execute when the condition is false, you can just throw a not in front of it, and that inverts the false to a true and the true to a false. So if you write a condition, so if I say if a greater than b, we'll have a and b, a equals 7, b equals 5. If a greater than b, I can say if not a greater than b, then I can print b is greater than or equal to a. Right, and this doesn't run because a is greater than b. So we're checking a is greater than b. This is true, not true is false. Right, so I have to make the other one the other way, like that. Cool. So not can be a useful one. It's kind of a silly example, but I just want to give you some sense of how to use it and remind you that it's there. I find myself using not fairly frequently, and an or somewhat, but I don't want to overload y'all just yet. You know, we'll get into those, but they're important to know about. So I guess on that note, did we do this? I don't think we did this one last time. Well, let's do it again. I'm not sure. I don't remember if we did this breakout last time. So this will evaluate to true or false. Got a couple minutes on the clock for this. Okay, cool. So I'll show you how I would think through this. So I'm looking at these parentheses. So if you remember PEMDAS, P-E-M-D-A-S, right? Obviously we don't have EMD or A or S, but we have parentheses, and we have other operators, right? So not evaluates before and before or. So not and or is the, so I guess we could, logical order of operations are going to be P in A R, P in R. Parentheses, not and or. P now. Okay. So I'm going to look for parentheses first. So innermost parentheses evaluates first. So here I see this set that goes to here, and then there's this other set that goes to here, and then there's this set which seems to be in parallel with this set. So these two are going to go first, right? And maybe we could just lay this out kind of in this fashion, just to kind of make this even more obvious. And then that and that, these are going to go first. Okay, so true and true. So remember our and truth table. True and true gives true. All other scenarios give false. Let's just do this for or really quick too. That'll be or. So true or true, and then just anything with a true and in the input is going to give back true, and false and false, false or false gives false. Oops. Let me square these out a little bit because I like to do that. Okay. There we go. So there's our truth tables. And then, oops. And then, of course, our not truth table is not true is false, and not false is true. So for reference, so I know this is going to turn into this. So true and true is true, so we'll replace that with true. Let's do this in steps 1, step 2. Let's do step 3. It's going to be true or false is also true. 4 is going to be true and true. So this is going to be, so true and true is true, and not true is false. But that's actually not what's going to happen here. This is going to be not true. That's what's going to evaluate, because not happens before and, right? So not true is false. And of course, false and true, false and true is false. Okay. Oops, I've got a lot of 4s there. That's going to be 5. Going to be 6. This will simplify down to not, we can get rid of that, not false is true. This will simplify down. True and true or true. So I see an and and an or, and the only operands that I see in here are true, so I can just deduce that this is actually just going to give me true. Like that. I could kind of work through that, but there's no other way because there has to be at least one false in there to determine that. So we'll just say that that simplifies down to true. whole lot more work than the final or true determines it's true. Yep. I wanted to go through that process though, because if you're thinking about your logic, sometimes it can be helpful to kind of just lay things out like this and just think through it, you know, when you're constructing something. Okay. Bitwise operations. Again, if you know what those are, there they are. But yeah, we'll leave that there. And we are, surprisingly, we are right out of time, right at this moment. Wonderful. Well, I think we did a pretty darn thorough job at covering some scenarios with if, elif, and else. We got through. I didn't actually like go through this, you know, scroll through this material, but we covered it nonetheless. I'll pull in the breakouts for these for next class, and homework links here in the class thread. So we'll do a little recap on this on Monday, and yeah, awesome. I'll wrap up there. I will stop the recordings.